Alright, so hello everyone. So in today's video, as I promised, we're going to cover loops. So one thing you have to remember, there are two main types of loops, two or three if you want to count the third one. First, I'm going to discuss the simplest form of a loop, and that's called the while loop. Now there are two types of while loops. There is the do while loop and then the regular while loop. So to illustrate this, we're going to make a very simple program that's going to print out the number we're currently at and increase it by 1 each and every time it does a successful loop. So to show this, we're going to use our trusty variable called num again. And here's the important part about loops. They have to start at some point, so I'm going to give it the value of 0. Because we want to start incrementing it from 0 up to a certain point. So now we can write the while. So we just type in while to call a while loop. Then give it a condition. And then put in the squiggly brackets as if we were doing it with the if statement. And then we do a condition. So basically you want to check that, I don't know, that our number is smaller or equal to, I don't know, let's do 6. Why not? And we want to type out the number. So to do that, we're going to use the cout function. And we're going to just give it the number, which is in our case num, and that's all you have to do. But that wouldn't be fun, would it? Because it would keep on going. To show you this, that it does that, we're going to compile our code. It's gonna compile, obviously, but if we decide to run this, it will just keep on printing out what it has. You can see it keeps printing out zeros, which is not what you want. Also, to make it look a bit nicer, we're going to add the end line thing so that it doesn't spit out zeros like it did now. So let's redo this and show you that it in fact does the same thing, but it prints out a bit more elegantly. You can see it keeps on printing out zeros, which is not what we want. And also, depending on how fast your CPU is, the faster it will go. But that's beside the point. You have seen it will keep on printing it out forever, pretty much. The C thing right here, you see here, I had to use Ctrl-C to exit out of it, if you were wondering. So to actually make this work, you have to do a fairly simple thing, and that is we need to increment our number. So to do that, we're going to do num, and I think ++ is the thing that we need to use. So let's compile this and see what it does. Whoops, I just compiled it without even testing it. And then there it goes. So you can see that instead of printing out zeros, it printed out from 0 to 6, which is what we wanted. So what happened? So if I were to comment this out, which you can do by 2 forward slashes before a line you want to comment out, which in our case is num ++ here. For demonstration purposes, I'm going to recompile this, and it's going to do the same thing it did before. Printing out zeros. And if I uncomment this and recompile this code and then run it, I accidentally compile it twice. You can see it prints out just numbers 0 to 6. So where is that? So it basically it sees that the variable num is at 0 at the beginning. Then it goes into the loop and it checks does our number variable, or num in our case, have the value of 0? So if it is actually lower than 6, so is the number 0 than 6? Yes. Write out my current value, which in our case is 0. Push me down one line and increment. Then do it again. Is number 1? You need to remember, it counts up. So 0 + 1 is 1. So is number 1 smaller or equal to 6? Yes, it is. Write it out. So write the number 1. Increment to number 2. Is number 2 smaller or equal to 6? Yes, it is. Write it out. And it keeps on going, and then it goes to number 6. So it increments to number 6, and then it goes, is number 6 smaller or equal to 6? It is equal to 6. Write out 6. And that's it, it's going to exit. Now watch what happens if I remove the equal sign. And I'm going to compile this again. And run this again. You will notice that instead of having the 6 at the end, we have 5. Well, the equal sign tells it go up to 6. Don't end before 6. So it pretty much ends at 5. So having it written out this way, it ends at 5. However, we wanted to print out all 6 numbers, so from 0 to 6. So let me just add the equal sign back in, and let's run this. It prints out all the way up to 6. A method you could write this out, like again, is we could in fact write another while loop. Another method of writing a while loop is with the condition at the end. To do this, we need to type in do, squiggly brackets, and here we'll type in while, and in here we're going to type on our condition, and we need to add a semicolon. And here we're going to check if the number variable is less or equal. I cannot type apparently. Less or equal, I don't know, let's do the other one. So let's do 10. And here we're going to, actually, yeah, let's keep it at 10. And we're going to copy this section of code again. And we're going to write it out. So essentially what I did here, it should print out till number 10. I say should, but I'm not really sure, because that's how I sometimes write code. I just write it and hope it will work. So let's print it out. As you can see, it did, and in fact did print out all the way up to number 10. So why is that? Well, you can see we have 2 while loops here, and the first one will write all the way up to 6. So all of these are done by this section of code here, which it does. We wanted it to print out all the way up to 6. And this section of code will continue from where it left off. So it will actually go in, and if we have a look at our code, you can see it didn't print it out again. It just wrote it out at 6. Then it incremented our number 6 and just continued, and it was like 7. Is 7 smaller or equal to 10? It is. Write it out. Is 8 smaller than equal to 10? Yes. Write it out. Increment again. Is 9 smaller or equal to 10? It is smaller. Print it out. Increment. Is 10 smaller or equal to 10? It is equal to 10. Print it out. Exit the loop. That's what the do while statement does. It's one of my more favorite ones because you get to define the statement at the end. So if you have something that checks for a form of an exit, this is useful if you wanna create menus in like a game or a application, because the user will still be in the menu until they exit, which is really helpful if you wanna make a program that does that. So with the while loops discussed, there's another form of a loop, and it's called the for loop. So let me just separate these out a bit more so it's a bit easier to follow. So let's create a for loop. Now a for loop is actually one of the more, I would like to say, more controllable loops, and one of the more used ones. And it's essentially the same as the while loop and the do loop, but without this, so you don't have to, you know, write this down every single time. If you're going to write a for loop, what you have to do is type in for, put in the brackets, the regular ones, then the squiggly brackets, and separate them again, therefore automatically moving us a bit down. So automatically formatting this for us, which is nice. So the difference between a while loop and a for loop is what's inside of these brackets here, and therefore making it look a bit more elegant once again. So what we want to do is, let's say we want to print out another set of 10 numbers. So instead of going like 6 and 4, we want to do another 10, so all the way up to 20. Well, we can use our, let's do So first we need to define a variable that's going to check against. Obviously, we want to do a integer. Normally we use the letter I. We're going to do that it's equal to 0. So this is the first statement, the first condition. It pretty much defines the first variable that it's going to use. Next comes the condition. The condition basically tells it do it up to a certain point. So let's say we want to check if I is less or equal to 10. Because we want to print out another 10 numbers, not 9 numbers. So by doing this, we're actually going to print out all the way up to 10 numbers, I think. And up to 20 numbers. Then I ended off with another semicolon, and here is the magic. Here we add essentially the what's it called? The method of incrementing. So it's going to just increment. We can either do incrementing or decrementing. So we can either increase the values or decrease them. So you could in fact reverse this if you wanted to, but we're going to just increment now because it's easier to do and understand. To do this, we just do I++, because remember we defined our I variable, so it has to be inside these brackets. So that's our thing defined, so the only thing left for us to do is just copy this one line instead of 2. And that's it. That's all we have to do. This is our for loop defined in just 3 lines of code instead of 4. Which may not seem like much, but it's actually a bit more elegant, a bit easier to follow. Because the user would be like, oh, so this thing gets executed up to 10 times. So instead of writing it out a bit more complicated like this, we can just write it out like this and make our code a bit cleaner. So watch what happens if I decide to compile this thing. So if I compile this and run it, well, what happened? Well, it in fact did print out what I wanted it to do, but it just kept itself there, which I didn't want to happen. Well, you see, that's the thing. It's not gonna increment our numbers, is it? Only thing it does, as of now, is print out the number 11, which is funny, isn't it? So it did not increment nothing at all. So what we need to do, in fact, is we need to add in our num++ thing again, because we want it to increment. We want to see it all the way up to 20. So it doesn't mean that if we have this thing here, it's going to increment our number as well. No, that's not how it works. This part here is special to itself. It's not available to anything else here. So our num variable will be equal to 11 no matter what we do here. However, if we add this to the end of it, it's going to be at 0. Check if it's smaller. It is smaller. Increment and then increment itself. Write out the current number, which in our case will be 1 higher. So it would be 11, which is what we wanted. Increase itself to 12. Check if 12 is small. Check then if I, it's a separate variable, so it's at 2 now, I think, or 1. No, it's at 1 or 2. It's at 1. So check if that checks out. Look, you get the idea. I just realized to make this work properly, we're not gonna put the equal sign here, because it's gonna print out 1 number more than we wanted. So by doing this, we actually managed to do it, because computers come from zeros to a certain number. So if I kept the equal sign there, what would happen is it would print out all the way up to 21. We want 20 exactly. So to do that, there are 2 methods of solving this problem. We could either change this to 1 and be happy with it, or we could keep this as 0 and just remove the equal sign. So it will do it just 10 times exactly as we want it to. You just have to remember that if you add an equal sign to it, it will do 1 more. So let's compile it and see what happens. So now when we compile this and run this, look, we got our set of 20 numbers all the way from 0 up to 20. Let me just resize this so you guys can see everything. Whoops. Let me just resize this. There we go. Okay, let's do it a little bit more. Let me just copy this. There we go. So you can see it executed as we wanted to. Start at 0 and increment up to 6, which it did, which this part of the code does. It keeps incrementing up to 6, so it will end off here. Then I wanted it to increment up to number 10, which was done by this while loop here. So it did just these next 4 numbers here, which is okay. That's what I wanted it to do. And then I wanted this for loop to do the rest of the job. So I wanted from it to execute all the way 10 times. So it started at 11, which was like it started at 10, which was like the 0 for it. And then it went up all the way up to 20, because it went up from like 0, and then it does 1, 2, 3, you know, you get the drill. So if it's equal to 0, it just prints out the number that there was, and there was the same number, so it didn't print it out again. What it did, however, is it increased itself to 11, and then it was printed out, which is what we wanted. So now we print out 20 numbers, all the way from 0 to 20, which is technically 21, but that doesn't matter now. From 0 to 20 using 3 different loops. Each one of them has their own use cases, advantages in certain types of applications. One thing you need to remember is if you don't want a certain thing to be executed inside of a loop, there's another method to the madness, and that is using breaks and continues. All you have to remember is that if you use a break here, for example, it will just exit this and do nothing. So let me just comment these out and just do a break. And watch what happens if I compile this. If I compile this, nothing has changed. If I decide to run it, it's not going to execute. It's just going to exit the loop. Now watch what happens if I put here continue. So let me just comment these out again. And so if I put in continue here, what's it gonna do is it's going to skip it entirely. Oh, I didn't compile this, sorry. And it's going to just do nothing, it's going to be stuck. So yeah, I wouldn't recommend this at all. Don't use continues and breaks if you don't have to. Basically just breaks on iteration, and I wouldn't want that to happen if I was going to print out numbers this way. Just, if you can, avoid breaks and continues, but if you are forced to use them, but don't use them if you're not needed to. Essentially what the continue statement does, it just breaks one iteration in the loop, and it basically skips, you know. It does a skip, you know. You can skip certain values if you wanted to, but who does that? I don't know. Let's just do this. Let's just skip the number let's skip number 14. To do this, we're just going to do if, and we're going to do that our num is equal to, now we need to put in the double ones, and let's do 14, and let's add the squiggly brackets. I just realized I goofed it up again. There we go, and let's do continue as a better example. There we go. So what will happen here is once it hits number 14, it's going to skip it. So let's compile this, run this, and watch what happened. As soon as it went to number 14, it just crashed itself out, which is fine, but like it like went outside the loop entirely, you know. So it kept on incrementing until it hit number 14. It just plopped itself out. So yeah, one method we could have solved this instead of our loop in particular is if I was equal to 4, because it's checking for something specific. So we're going to do I is equal to 4. Let's compile this again and let's run this, and so 0, 1, 2, 3, 4. It did not skip at all. In fact, what you might have noticed is it went up to a certain point and then it didn't print out the last number, which is not what I wanted, but it's okay, I guess. So, you know, I wouldn't necessarily recommend it. Again, these exist because of a reason. I wouldn't use these in particular in this example, but they do exist, and I figured that if I don't mention these, people are going to be angry at me if I don't. So that's all I have to know about loops, and I hope this wasn't a bit too confusing. I just tried to keep it as simple as possible. In the next one, we're going to discuss arrays, where we're going to also use loops to print out arrays and stuff, and then we're going to discuss pointers and functions and classes and such. We're going to discuss pretty much everything we need, and I hope to see you guys in the next one. And yeah, just make sure you stay safe and have fun and keep on coding.